Okay, so yesterday I drew the picture for you for number 4 and I started to explain how to do it. So let's just make sure you know how. So the buddy, what was it? The pleasure boat went 2.7 kilometers south, then turned at an angle and went 3.4 kilometers south, 26 degrees east, and then turned again and went 1.9 kilometers east, 12 degrees north. And what I had said in yesterday's video was break this one up into its x and y components. So this will be y2, because this would be y1 up here, and this would be x2. And then break this up into its x and y components. So this would be y3, and this would be x3. And now find those components. So if we take a look, this y2 is the adjacent side. And you have the hypotenuse, so adjacent should be cosine. So it should be cos of 26 is equal to y2 over 3.4 kilometers. So y2 should be equal to 3.4 kilometers times the cos of 26. And if you do this in your calculator, you should get 3.056 kilometers, and that's south. Then you do x2, and it will be sine. So sine of 26 should be equal to x2 over 3.4 kilometers. So x2 should be equal to, that really is an x, 3.4 kilometers sine of 26. So x2 should be equal to 1.49 kilometers, and that will be east. Then you're going to do the same with your y3 and your x3. Just be careful though, because now your x is on the adjacent side. Your x is going to be the cosine, and your y is going to be the sine. So it'll be sine of 12 is equal to y3 over 1.9 kilometers. Or y3 will equal 1.9 kilometers times the sine of 12. And when you do this, you get 0.395 kilometers, and that's north. Okay, so we have a south, we have a north, and over here we have another south. In the x, x2 was 1.49 east, and our other x3 this time is cosine. So cosine of 12 is equal to x3 over 1.9 kilometers. So x3 is equal to 1.9 kilometers times the cos of 12. And when you punch this in, you should get 1.8585 kilometers, and that is also east. Okay, so now your next step is to add up all the easts and add up all the x's, add up all the y's. So if we do a total in the x direction, they're going the same way. So the total in the x should be 3.3489 kilometers, and that's east. In the y, we have 3. We have this one over here, that's a south. This one here, that's a south. This one here, that's a north. So when we add them up, you're going to have to take into account the different directions. So if you call south negative, then these two would both go in as negative. This would go in as positive. Add them together, and you get 5.3609 kilometers, and that will be south. So now you want to draw your new triangle. So you have a south of 5.3609 kilometers, and you have an east of 3.3489 kilometers. And then this is what you're looking for in this angle. So you're going to square them, add them together, and take the square root. And when you do, you get a resultant of 6.321 kilometers. And then find your angle, and that angle ends up being 31.99 degrees, or 32. Which direction were we going first? South. Which direction after? And that is east. Okay? So if we take a look, determine the boat's displacement for the entire journey. There it is. And displacement has to be both the length, the displacement magnitude, and the angle. Okay? In what direction should the boat be pointed to head straight home? To go straight home, you're just going to turn this around. You're going to go north instead of south, keep the angle the same, and then go west instead of east. So this is the answer to part B. All right, number 2. A jet ski driver wants to head to an island in the St. Lawrence that is 5 kilometers west, 20 degrees south. So I started to draw this for you yesterday. So west, 20 degrees south would be like here, where this angle in here is 20 degrees. Okay, but then it says he's traveling at a speed of 40 kilometers per hour relative to the water, and the St. Lawrence is flowing 6 kilometers per hour east. So if he aims for here, he'd end up too far east. So he has to aim for further west. He has to aim up here, and then the river will carry him this way. So this is 6 kilometers per hour east. What he can do with respect to the water is the other side of the triangle, and that's 40 kilometers per hour. Okay? And the first part of the question wants to know what direction should he head. In other words, what's this angle in here? Now, before we can find that angle in there, we should find this one, right? Because if we find this one, then we can take it away from the 20 degrees and find out what angle should he head. This 20 up here is also down here, which makes this 160. We now have an angle in its opposite side, a side, and we want the opposite angle. So it's going to be sine law. So sine A over 6 kilometers per hour will equal sine of 160 over 40 kilometers per hour. So sine of x will just be 6 kilometers per hour times the sine of 160 over 40 kilometers per hour. And then find x. So 6 times 160 sine divided by 40. And then do inverse sine. And I think you get 2.491 degrees. So that's x, but we want theta. So theta is going to equal 20 degrees minus the 2.491 degrees. So theta is going to equal 17.06 degrees. Okay? Now we also need a direction, so which way? Well, that would be square brackets west, 17.06 degrees, and then south. So that's the answer to part A. Part B says, how long will it take him to reach the island? Well, it told us in the question that the island was 5 kilometers away. Okay, so that's the length of this side. So we could use V av equals delta D over delta T and find delta T. Delta T would just be equal to delta D over V av if we knew the speed on this side. So before we can use this V av equation, we need to find this V. So we can go back again and use either this time sine, you can use sine law or cosine law this time, because we now have all our angles. Because if we know x and we know 160, then we know that this one down here must be 17.06 degrees. So the easiest one is probably sine law. So V over the sine of 17.06 will equal 40 kilometers per hour over the sine of 160. So V is going to equal 40 kilometers per hour sine of 17.06 over the sine of 160. And I think I did that right. Just let me double check. Yeah. Okay, so we're going to take sine, multiply it by 40, divided by 1/6.